Okay, guys, can you see me and hear me? Just let me know. Guys, can you see me? Hello, everyone. How are you all? Good evening, Shagun and Khushika. How are you? Hello, 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 everyone. So we are going to discuss about work, energy, and power. And this is the first session of this chapter. We'll be having two sessions and we'll be covering the important topics that are supposed to come in NEET. Okay. Good. Fine. Very good. Very good. That is good. That is good. You are in 10th IIT NEET Foundation. That's good. You started early, but that is great. Okay. Thank you so much. Okay, Abhishek. Okay, so let's start with it. Okay, without any further delay, let's see if you guys can learn something new. Okay. Okay. Okay, so the first thing we are going to discuss here is work energy theorem. I am good, Abhishek. How about you? Good afternoon, Rianshi. So everyone just settle down so that we can start, right? Okay. Please make me compatible for upcoming exam. Niyati. Okay. I got it. ठीक है. Abhishek Jaiswal is fine. Okay, so let's start with it. We are going to discuss the first thing that we are going to discuss is work energy theorem, and this theorem is simple, but why actually we are using it? Okay, so what happens is sometimes I'll just keep on writing. Sometimes kinematics becomes easy, not easy. Okay, becomes tough, and for those situations we need work energy theorem. I am good, Chandani. Okay, so you guys are getting it? Okay, it's boring. Physics is boring. You find physics boring? Pratham, don't say that. Physics is the most interesting subject you can get, beta. Okay, please say some important topic for NEET. Okay, so from this chapter, it is work energy theorem, and then the circular motion, then power. Okay, these things will be coming up. Everyone just settle down. Very boring. Niyati also find it boring. Okay, just keep attending the session. You'll find it interesting in a few minutes. Okay, Anand, that's really good. Okay, let's start with it. So work energy theorem says the sum of work done by all forces acting on each particle of a system of particles is equal to the sum of change in the kinetic energy of each particle of the system. So I'll start with, okay, voice is not clear. Okay, just refresh from your end, beta. Okay, so I'll start with a question. Suppose there is a mass of 1 kg, okay, and it is moving with 1 meter per second velocity. Okay, initial velocity is 1 meter per second. Suppose I deliver a work of, let's say, 20 joules. So can anybody from this audience, can anybody tell me what will be the final velocity and how are we going to do that? Chandini, just keep listening. You'll find it interesting. Okay, I'll try my best to make it interesting for you. Okay, so just tell me, Chandini, what will be the final velocity if we do a work of 20 joules? Go ahead. Let me know if you guys can do it. Okay. Okay. Anyone who can say or who can tell me what how it should be done? F is equals to ma. Okay, so Dilip is going to, you can say, enter into laws of motion and kinematics. Okay, this is why I was telling you we are going to use work energy theorem. Okay, so what does it say? Work done is equals to change in kinetic energy. Change in kinetic energy means kinetic energy final minus kinetic energy initial. Okay, and work done is 20 joules. Are you guys getting it, what I'm trying to say? Good, Meghna. Good. Everyone keep listening, okay? Root under 41 meter per second. Movie maker, you seem to be a good student. Very good. Keep it up. So what is the final kinetic energy? We don't know, right? We are interested in finding that only. So Vf minus half mv square or u square, let's say. Okay. So what is the initial velocity? Let's put those values. Minus half m is 1 and u is initial velocity as given in the question is 1 meter per second. Okay. So let's calculate it. Okay. So it becomes 40 by m, that is 1, that is Vf square. Okay. Vf square and minus 1. So V final square will become 41 and Vf will become 41 root under. Yeah, you guys were correct, and that's absolutely awesome. So now let's see, have you guys understood the concept of work energy theorem? Why are we using it? And what's the big deal about it? Are you guys getting it? Okay, so to avoid kinematics, we use work energy theorem. Okay, it makes the calculations very easy. We can get the answers very easily. Okay, let's see the application of this thing in a NEET question, which came in the year 2017. Okay, so let's see how many of you can do this one now. Gautam, Shreya, you guys gave me a correct answer. That's really good. So let's see if you guys can get me a correct answer for this one. Okay, so just give a try. In the meantime, I'll also you can say keep on telling you what to do. Okay, so you need to find the work done by gravity plus work done by air. Air is our resisting one. D is correct. Okay. Nagma, how you came up with an answer? Go ahead and tell me. So what will be the work done by gravity on this one? Okay, if you guys have not read the question, let's read it first. Okay. Consider a drop of rain water having mass is equals to 1 gram. Okay. Falling from a height of 1 kilometer. So here is a tip for everyone. Okay, once you are solving a question from physics, if you are reading the question, so write every parameter which is coming in the question. Okay, so as I'm doing. Okay, so the first thing I came up with is the mass. So I wrote mass is equals to 1 gram. Then it is coming height is equals to 1 kilometer, that is 10 raised to the power 3 gram. Has given one term of physics and okay. So 10 raised to the power minus 3 kilograms. So first, another tip for you is always convert all the parameters in SI units. Okay, so I am doing it, you guys can see. Okay, so first thing I converted is mass from gram to kilogram and then kilometers to meters, because we need to convert it into SI units. Now let's read the rest portion. Okay, it hits the ground with a speed of 50 meter per second. Take G as a constant with a value of 10 meter per second square. The work done by gravitational force. So first thing we need to find is the work done by the gravitational force. And the next is resistive force of air. So how are we going to proceed? Can anybody guide me? Is there anyone who can guide me with this one? Okay, so first, or the only thing is work done by gravity, that is mgh. Okay, what is the mass given in the question? 10 raised to the power minus 3. G 10, height 10 raised to the power 3. So what is the answer coming for work done by gravity? Work done by gravity, I have not even talked about air resistance. Okay, we will discuss about it. Okay, so by now I have work done by gravity and it is equal to 10 joules. Okay, are you guys fine with it? MJ, it's simple, right? Even the student of, you can say, 9th class can do it, because this work done by gravity is discussed there as well. Okay, now to finding, or you can say to find the work done by air, we need to apply work energy theorem. Okay, so work done is equals to change in kinetic energy. Change in kinetic energy means kinetic energy final minus kinetic energy initial. Okay, and work done, what all are the forces that are acting? Gravity and air resistance. Okay, we just found work done by gravity and it was coming out to be, or it is coming out to be 10 joule. Okay, Hemanand, Hemanand, beta velocity is given as 50 meter per second. Okay. So yeah, hold on, Shreya. Okay, so work done by air we need to find, and we can very easily see that kinetic energy initial is 0, but kinetic energy final, the parameters are given in the question. Okay, so half mv square. Let's see what are the values of these. Okay, mass is given as 10 raised to the power minus 3 kilogram. Okay, and what is the velocity given in this one? Everyone, that is 50 meter per second. So 50 square. So guys, can you now, are you guys getting it? How to find the work done by resistance, air resistance? Okay, Nagma, you solved it. Very good. So that's really great. Okay. So it will become how much? Calculate it. Okay. So it will become 1 by 2 into 10 raised to the power minus 3 into 2500. Okay, very good, very good. So it will become 1250 into 10 raised to the power minus 3, that is 1.25, okay, minus 10 joules. So work done by air, it is coming out to be minus 8.75 joules. Okay, so which is the correct option, which is matching our answers? Okay, you already know that. So wait for the next one, beta. Okay, you may not be knowing the next one. Okay, good. So I hope you guys understood it. It's a simple one where we need to just add all the work done. Okay, Chandini, what are you asking? You are sending me a smiley writing answer, please. Okay, so shoot the question again, beta. I must have missed the chat. Okay, let's move to the next one. Okay, let's move to the next one. And this is relatively, I'm scared of physics. Keep practicing, beta. Keep practicing. Solve at least 15 to 20 questions every day. Your fear of physics will fade with time. Okay, don't worry about it. Nagma. Okay, let's move to the next one. Second concept we need to discuss is this one. You can send it again, Chandani, beta, because I missed it and I cannot scroll down the chat, beta, right now. So power, what is the formula for power? Power is force F dot V. Okay. How many of you know this thing? Just let me know so that I can proceed with the question. D is the answer, beta. Krishna Kant, D is the answer. Shreya, you're also scared of, okay? In exams, you cannot solve numericals. Keep practicing, Nagma. That's the only key, okay? There is nothing else. There is no shortcut, okay? Okay, let's move to the next one, the question in hand, okay? So let's read the question, everyone. Okay, so a body of mass 1 kilogram. So first thing is mass 1 kilogram begins to move under the action of a time-dependent force. So force is given as 2t I cap plus 3t square j cap, where I and j are unit vectors along x and y axis. What will be the power? So guys, you have any idea? And do you guys have any idea how to find the power of this one? Yes, Chandani, just share your you can say thoughts. How are you going to proceed with this one? Or is there anyone else who can just tell me? Okay, so we are given with force. Okay, we are given with force, and force is nothing but mass into acceleration. Okay, so I'll just find velocity from the same expression. So acceleration will be 2t I cap plus 3t square j cap by mass. Okay, and mass is given as 1, so it won't make a difference. So acceleration will be same as this one. Okay, 3t square j cap. Now, what is the relationship between acceleration and velocity? Can you guys tell me? dv by dt is acceleration. Very good, Pooja. You are correct. Very good. So just replace it. So we can write dv by dt is equals to 2t I cap plus 3t square j cap. Okay. Now what we need to do, the basic integration. Okay. 2t I cap plus 3t square j cap into dt. Just integrate it. How many of you can integrate this basic integration or basic, you can say, expression? Can anybody guide me in this one? That will be t cube j cap, and that is velocity. How many of you agree with that? लगा ही था दिलीप, आपको लग रहा था ये आंसर होगा? That's really cool. Okay. Okay. Now we are interested in finding power, so we'll just use the basic formula. Okay. F dot V. Okay. So F is 2t and 3t square. Okay. J cap dot t square I cap plus t cube j cap. So guys, can you tell me the, you can say, dot product of these two? So it will be 2t cube plus 3t to the power 5. Okay. So power we are getting is this much, and the unit of power is watt. Have you guys understood it completely? Is there anyone who is having a doubt or something in this particular question and topic? There are a few students who are asking me about magnetic fields. So we will be having sessions of magnetic chapters as well. We'll be covering entire thing. So just hold on, okay? Try to learn work energy for the time being. So that physics may tell me how do you join your class, okay? I didn't understand Niyati. It's a simple one. Just find velocity by integrating the expression of acceleration and then find the cross, or you can say dot product, to find power. Let's move to the next one. So how many of you know this thing, this simple thing? I assume that you guys, everyone knows it. So what should be the velocity at the bottom so that the particle reaches position 1 and position 2? Just reaches. Krishna, where are you confused? You guys are asking me to explain. I see that most of you are asking me to re-explain. So I'll just cover it up again, okay? So everyone just see. Okay. So force is given. Okay. Force is equals to mass into acceleration. This time everyone follow it, okay? Keep listening so that you can get it. Now acceleration is this much by mass, okay? And acceleration is 2t I cap plus 3t square j cap. So we just found acceleration. Now acceleration can be written as dv by dt. Now I am just integrating it, okay? So we can multiply something like this, then we integrate it. I assume that you guys know these basic integrations, okay? So velocity is coming out to be, okay, so there is one kid who is having an issue with the integration part. So beta, it's a simple one. What is the integration of 2t with respect to dt? So it is t square by 2 into 2. So these two cancel, so it is t square only. Coming to 3t square. So it is 3t cube by 3. So it is t cube only. So that's why we are getting the velocity, something like this. Yes, Shreya now got it. So you have velocity, you have force, just find the dot product. I hope you guys are good to go, okay? So let's move to the next one, okay? So how many of you have any idea about this thing? What should be the velocity of the particle at the lower, or you can say bottommost point, such that it reaches P1 or position 1? Everyone got it? Very good. Very good. Now you guys are on getting it. So what should be the velocity V bottom so that it reaches position P1? So it is root under 2gr. It is basic, okay? It is very basic. Everyone who has studied this chapter knows this thing. And what should be the velocity at the bottom, minimum velocity at the bottom, so that it reaches point P2? So it is root under 5gr. So I am now going to the next question. Let's see how many of you can answer it. It is a question that was asked in NEET 2016. And guys, tell me, are you finding it easy or tough? Go ahead. What is the minimum velocity with which a mass of, you can say m, must enter a vertical groove? Yes, you just scored, you can say 4 marks, okay? Meenakshi, Shreya. Okay, Meghna, just see it again, beta. C is the correct answer. Very good. Very good. Now, I hope you guys are fine with this question. It was a simple one, and it was like everyone can do it. And let's move to the next one. So, how many of you know the basics of work? Everyone, okay? So, work done is F dot S, or work done is F dot ds integral when force is variable. Okay. Okay, let's see a question. It's easy, right? Nagma, you're finding things easy, so why are you scared of physics then? You're doing good, beta. Okay, so work done is equals to F dot ds, and when the force is variable, and if it is constant, so F in F dot s. Let's see a question based on that. So how many of you can do this one now? Let's see. Let's see how many of you can find what is ds and this thing in this question. Okay, so don't know, Nagma? Okay, so you're saying that you don't know why you are scared. Okay, that is fine. A particle moves from position, you can say from a point r1 is equals to minus 2i cap plus 5j cap, and r2 is equals to 4j plus 3k cap. Okay, so how many of you can tell me what will be the displacement vector? Nah, it's not hard. Keta, it's not hard. Displacement vector, you just need to find displacement vector. Just find it, displacement vector. Okay, Sanjay, pay attention, beta. You're asking me to repeat. So a particle moves from a point minus 2i plus 5j to 4j plus 3k when a force of 4i plus 3j Newton is applied. Okay, how much work has been done by the force? So for that, we need to find the position vector, and the position vector will be R2 minus R1. Okay, so what is R2? That is 4j plus 3k cap. And what is R1? So R1 is minus 2i plus 5j. Okay, so let's see what it is. So 2i and j here, but a negative sign. So minus j plus 3k. Are you guys getting it? Very good. So displacement vector is coming out to be 2i minus j plus 3k, that is s. And what is force given? A bit tough. No, it is not tough, beta. You just need to find displacement vector, that is R2 minus R1. 4i plus 3j is the force. So force is given as 4i plus 3j. Now you guys know how to find dot product. So work done is F dot S. Okay, what is F? 4i plus 3j dot product with 2i minus j plus 3k. Okay, so just tell me what's the answer you guys are getting. So it is 8 minus 3. That is minus 5. I'm writing, I'm saying minus 3. It is minus 3. Okay, joules. So work done will be 5 joules. So guys, just tell me, we did like 4 questions and few important concepts. So did you guys learn something today? You got something? So this is it. Okay, this is it for today's class. In the next session, we'll be discussing the remaining portions. Okay, many such interesting questions will be discussed. Okay, so be there in the next session, and till that time, everyone, goodbye. Okay, so we'll meet in the next session. Tab tak ke liye take care. Good night. Have fun and stay awesome.